next speaker to have a wireless vision talk, and I'm happy to invite Professor Arogyaswamy Paulraj, who is a wireless visionary from Stanford University. Professor Paulraj, as you switch on your video and audio, I would take a quick second to introduce you. Uh, Paulraj is an emeritus professor at Stanford University. He is the inventor of MIMO, the multiple input, multiple output, which is the key technology in the all modern wireless systems, right? He is known as the father of MIMO. He has received multiple national level awards from the US, Chinese, and the Indian governments, including the Padma Bhushan Award. His other recognitions include the Marconi Prize and the IEEE Alexander Graham Bell Medal. He is a fellow of 9 national science and engineering academies across the world. Paulraj founded 3 wireless technologies companies in the Silicon Valley between the 1980s to 2015 that were later acquired by Intel, Broadcom, and HPE. He has served in the Indian Navy from 1965 to 1991, working on sonar technology and founding 3 R&D laboratories: the Center for Artificial Intelligence and Robotics, which was later became DRDO, Central Research Labs, which is Bharat Electronics, and the Center for Advanced Development of Advanced Computing, which is CDAC. So pleasure to have Professor Paulraj here. Sir, over to you.
Thank you. Can you hear me?
Yes.
Okay. And I'm supposed to share some content. I'm trying to bring that up. Just a minute. I thought I'd opened it.
As Professor Paulraj is bringing up his slides, I hope each one of you were able to see the poll that we launched on the auditorium. It's on the right side of your screen. You can respond to that poll. To remind you, you can post your Q&A so that I bring it up with the speakers from the Q&A box that we have. We will have limited questions, but definitely we want to hear from you, and some questions we'll answer as we go during the day. With that, I see the slides from Professor Paulraj coming up. So, Professor, over to you.
Okay. Can you see the slides also? And me,
yes.
both?
Yes,
both?
I can see
Okay,
both of
good.
you in full screen.
So, good evening, and distinguished guests and ladies and gentlemen. My particular greetings to Vinod Dham. I guess both of us are here in the valley suffering the heat. And also hello to Nivruti. I've not met her before. My talk is targeted at the national level, the Prime Minister and the Prime Minister's organization office, in a follow-through of my interactions in Delhi over 2018 and 2019. And so my material is really relevant at the national level. And my apologies to the industry audience here for presenting material that you will mostly know or may not be very interested in. But let me begin. So it's really a privilege to speak at this event, though virtually from Stanford. And I want to thank Mr. Satya Gupta, chairman of the Indian Electronics and Semiconductor Association, for his invitation. Your association represents the global industry operating in India and bringing value to our country. And I hope that ISA will become an effective voice for Indian electronics, both nationally and internationally. Like in India, like many other countries, the COVID pandemic is a once in a century challenge. And I hope and I'm sure that India will soon bounce back and be on track to build a united, prosperous, and a secure society for all our citizens. So my remarks today are, again, I said, aimed at Delhi and follow up many meetings I had there. Is on core ICT, core information and communications technology, or core ICT industry, which is just a fancier name for the electronic industry. And I will examine India's status and aspirations in this area. I'll address the dominant civilian ICT sector that touches almost every citizen of India and not cover the smaller defense and industrial electronic segments. Before I start, it's worth recalling some history. Self-reliance in core ICT has been a priority for our country since we gained independence more than 70 years ago. Beginning in the 1950s, thanks to the influence of Dr. Homi Bhabha and others, the Indian government set up national laboratories in defense and basic sciences by technical universities like the Indian Institutes of Technologies and public sector units to advance this industry. The very first public sector unit in India was indeed the Indian telephone industry, set up in the 1950s with its headquarters in Bangalore. Later in the 1980s, the government set up a government R&D lab called the Center for Development of Telecommunications, or Telematics, I think. And the country saw early payoffs from these investments. I will highlight three. In the 1960s, TIFRAC, an experimental computer system developed at TIFR in Bombay, gained international recognition for its innovative computer architecture. And in the 1970s, India developed an anti-submarine sonar, APSO, a massive system for its day. In that era, thanks to the Cold War between the superpowers, sonar technology was crucial battleground since submarines carrying nuclear missiles posed an imminent threat, imminent mutual threat. And indeed, in the 70s, the sonar technology was a strategic technology, much as 5G and AI are today. So the Indian APSO technology was clearly superior to that in the Soviet Union and Europe, and likely ahead of that in the United States. APSO was the fleet sonar of the Indian Navy, became the fleet sonar of the Indian Navy. It was a major success. India did not import sonar technology for at least 2 decades, thanks to the foundation of APSO. The details of APSO, nearly 40 years after it entered fleet service, are still probably classified. But here is a layout of a second generation US sonar called SQS-26. And APSO was the third generation system and had more advanced signal processing displays and had dual cylindrical phase arrays that are hull mounted and towed. These were massive systems costing tens of millions of dollars. And India actually was ahead of the world at that time. That linked to my two mouses here. So in the 1980s, India also developed, I should go back here, developed a telephone switch called DSS Max. It had a 40,000 subscriber capacity. It went into service in the early 90s. I think with over 25 million lines in the telephone network. Max was a huge success and incorporated many innovations in the switch fabric and environmental ruggedness suitable for developing countries. So with this piece of history, let me get back to ICT today. So ICT underpins every important vertical in India, bringing economic opportunities and societal benefits, and is a transformational force for Indian society. It can help the country leap forward the traditional barriers, the development as well as advance the digital vision, India vision of the Prime Minister. We can organize ICT into 3 layers, the application layer in the top, with India's key verticals, first the economic vertical, and the societal vertical, and the security vertical. And these verticals are all big users of ICT. Some common applications we all use are like e-bank, online banking, e-commerce, and WhatsApp. The The applications, in turn, are built on ICT services, and these are provided by service providers. Some examples are wireless networks, internet fabric, cloud data centers, and AI type servers. Examples of AI service providers in India are Jio and Google Cloud. And AI is still early in its maturity, but it's likely to grow in value, touching many applications. These ICT services, in turn, use core ICT products, such as base stations, routers, blade servers, phones, laptops, etc., that are built using semiconductors like ASICs and FPGAs, processors, etc., and also advanced components in optoelectronics and sensors. The big frontier for core ICT systems now, for example, is Cloud RAN for 5G. We will need a new class of servers with many teraops capability to support wireless networks, which provide multi-gigabit throughputs per second. The important thrust in semiconductors also includes special purpose engines for deep neural networks, where Stanford is very heavily involved with, which can handle model sizes in excess of 150 billion nodes and petabytes of training data. And also things like co-packaged optical transmissions, where we can do multi-terabit per second connectivity from a single chip. And of course, the industry itself, the semiconductor manufacturing industry now is in 7 nanometer node, in fairly routine mode, and 4 nanometers are coming into production. I refer to this layer as core ICT, and is the focus of my remarks today. So core ICT delivers hardware along with embedded software and firmware, ultimately the distillation of intellect and knowledge of hundreds of thousands of engineers around the world. Let's examine the structure of this industry. So we can view this in two layers: the design companies that deliver and hold IP, and manufacturing companies that convert designs into end products. The design layer can split vertically into systems design, examples of Cisco and ZTE, or semiconductor design, examples of Broadcom and HiSilicon. Likewise, manufacturing layer can be split into semi-fabs, TSMC and global foundries, or component suppliers, particularly like Sony and Hamamatsu, who build displays and optical components. And finally, assembly and test factories like Foxconn and Electronics, where the end product gets put together. So China became a big hub in assembly and test, but more recently, Vietnam, Thailand, and Cambodia are growing rapidly. India, too, is now building an assembly and test base with Foxconn and Samsung having set up facilities. The total value addition or earnings in core ICT is about 1.78 trillion in 2020. I mean, that's my best guess. One industry that has grown despite the global pandemic. And the revenue share of different layers and segments is about 1 trillion for the design layer, $650 billion for system design, and $350 billion for the semiconductor design. And about 780 billion for the manufacturing layer, with 550 for semiconductors, 150 for advanced components, and 80 billion for assembly and test. The assembly test segment tends to use lower skilled labor and also adds low value add. But of course, there are exceptions like test program generation. But the factories themselves are very highly automated and use very advanced manufacturing technology. Assembly and test can bring to India much needed jobs, particularly for women who excel in full assembly lines. So India is well set to expand this segment with tax incentives and exploiting shifts in the global supply chain. But we do need to keep our labor costs competitive. I will not discuss assembly and test in the rest of the talk. It is not strategic to the country, and focus more on the design layer and the manufacturing layer, other than assembly and test. The core ICT system is globally intertwined, and it's useful to examine its cost structure. And let me begin with that of a smartphone. So consider a high-end phone, say a brand XYZ, its approximate selling price is $600. Of the $600, 210 goes to, let's say, XYZ, who uses it for 85 for R&D and IP, and the balance 125 for sales, marketing, and profit. The actual phone itself is manufactured by, say, Foxconn, a contract manufacturer, And he will deliver that phone to XYZ for $390. And Foxconn itself will get about $30 for its effort. And the balance 360 goes to component suppliers, 50 semiconductors, 45 display, 65 other components like sensors and camera. The Foxconn then manufacturer only gets about 5% of the $600 phone value. So many companies come together, get that smartphone into your hands. XYZ will source IP, electronics, and mechanical components, and tools, and services from over 20 major suppliers, who in turn depend on another 50 other suppliers. So about 70 companies participate directly or indirectly to deliver the phone. These companies are headquartered in countries like United States, China, Japan, European Union, South Korea, Taiwan, Israel, and Singapore, the club that constitutes this ecosystem. This understanding, let's examine this core ICT supply chains and its characteristics. I'm excluding again assembly and test. So this is currently spread across, as I said, a few countries, and about 1.7 trillion revenue, and an annual R&D spend of about $300 billion. Such an annual R&D investment implies that the accumulated R&D base supporting the building of today's products is probably about 1.5 trillion. And so India is not a member of this club. We've been talking about it for 30 years, but I think we made very little progress. And I think it's high time we change that. So we're not a member of the club in the sense that we have no significant Indian headquartered companies that participate in this $1.7 trillion industry. And almost any significant company in this club is a multinational company spread across the world. So core ICT is a tightly interconnected system of participant countries, and no country in this club is an independent island. So that brings me up to what I was talking about in this talk. My title was Indian electronic industry, so interdependence or self-reliance. So this point brings up that issue. So the industry is largely in the private sector. Government should be investing, and the only model that works, but very exceptions of public-private partnerships in semiconductor fabs. The industry is dominated by over 100 large multinational companies, who in turn rely on thousands of smaller companies. I know in China, people tell me that there are companies in China which are built on thousands of other companies. So I'm going to verify that. And these other smaller companies offer components, tools, and IP. I myself have built some companies here in the Valley. This is, of course, an ultra-competitive industry where only the best survive and operate with the winner-takes-all dynamic. These companies operate globally, but they remain under the control of the government of the country where they're headquartered in. Country motivated by national security, the government motivated by national security or geopolitics can prescribe the company's international sales and operations. For example, the US government recently restricted access of certain countries of technology owned by US headquartered companies. And ironically, even when a company A designs a piece of technology entirely in its offshore R&D in country B, say India, the company A can be blocked from selling that technology to country B. That is the reality of today's world. And there are, of course, huge entry barriers for new players into this core ICT ecosystem. Massive accumulated knowledge and IP, including standards essential patents, very high but risky investments, in particular for startups. A lot of IP litigation, and many of us, including me, have faced that. The trade and technology transfer barriers, which is now increasingly being asserted, and WTO regulations. Finally, let's examine core ICT, with this background, what's happening in core ICT in India. Despite some impressive achievements in the 60s, the 70s, and the 80s, in India's core ICT capability, this has declined since to relative global levels in the 1990s. We were much better off before the 1980s. This is not time to go into why this happened. However, there are now increasingly urgent reasons in India, like national security, to rebuild this capability and to begin to participate in this global ICT ecosystem. It's time to get real and not keep talking. This technology underpins every aspect of India, its economy, its society, and its security. Core ICT is the foundation. Moreover, Core ICT is the foundation for all our sensitive security subverticals like defense, cyber, intelligence, nuclear, and space. Therefore, our heavy dependence on imports creates many vulnerabilities. Also, ICT is the key enabler of high-growth frontier technologies like bio, robotics, nano, and energy. These technologies are all intertwined and interdependent, but ICT is a critical foundation. Biotech is growing in independence on large compute and AI. Robotics ever reliant on machine vision and AI. Nanotechnology again uses high-performance computing for modeling and design space exploration. And finally, energy at the core of our economy, where alternate sources of energy, energy efficiency, storage, propulsion, all increase are dependent on ICT foundation. For all these reasons, the Honorable Prime Minister, through Make in India and more recently Atmanirbhar Bharat, has emphasized the urgency of India to build some capability. Today, India imports pretty much all its core ICT to power our internet, our wireless, our cloud services. Excluding defense and industrial electronics, this import bill is about $50 billion in 2019. There's been some local value addition, but mostly in assembly and test. There is no real technology contributions from Indian headquartered companies. On the positive side, India hosts huge offshore R&D operations by foreign headquartered companies like Intel and Broadcom. This may have been a significant economic boost for India, bringing high-paying jobs, and also building a knowledge base in this advanced technology. So we certainly welcome them. And the Indian headquartered IT services companies like Wipro and Infosys, and I'm sure they're taking part in this ISA meet, who have also done India proud, have in the flourishing practice in engineering services, and also undertake contract R&D in everything from advanced chip design to product technology upgradation. But given their services model, they're not generally product-oriented or IP-focused. However, in recent years, this is changing. One example of this is Tech Mahindra. Also, Indian universities like IITs have become active, at least in wireless research. I'm fairly involved with them. And a proposal for increasing the rural coverage of 5G, called LMLC, is under consideration by 3GPP standards and has already been approved by the ITU. India also has a few small companies in core ICT, like Tejas Networks, that builds optical switches. And there is a good product group within Geo, and which I recently talked to, and they're working on 5G technology. So given this picture, India's best bet to enter the core ICT ecosystem, and is really about entering, because right now our base is very, very low, is to grow new companies which will expand on existing industry efforts in this area. We need entrepreneurial university researchers and engineers from industry, and we even need also international talent, much as it is in the Silicon Valley. India also needs more business development, product management skills, which should be attracted from outside the country. The initial opportunities for India will be in, I think, the design layer, systems design and semiconductor design, where a lot of engineering skill sets are largely available in India, and the investments are somewhat smaller. I know, however, semiconductor and other component manufacturing is important too, of course, but will require much more careful planning because to build this sector, I know Vinod talked about it, it'll take time because of the low existing skills base in our country. We compare what's in India to what there is in TSMC or in Intel or Global Foundries, we have very little skills base and also very high investments. So India has had repeated attempts to do something about it, but I think we still don't have anything world class. So this will take time. So India, to become a genuine member of the Core ICT Club, which we all want, It will mean building a few Indian headquartered multinational operations, which can command a fair share of IP and standard central patents. Only then we arrive. Till then, it's all talk. This brings me to the core question on what is an appropriate model for core ICT industry. What would self-reliance imply, which is India's goal, imply in the context of a global ecosystem that's built on interdependence? Some leading indicators are informative. India's total R&D spend, which is government, public, and private sector, excluding the foreign companies' offshore R&D, is about, in all technologies, is about 15 billion in 2019. It was 14 billion in 2018. And more than half of that goes to defense R&D, or defense DRDO. So that leaves about 6 or 7 billion for everything else. So the core ICT share of Indian R&D in core ICT is probably less than $500 million per year across the entire government, public, and private sectors. In contrast, the global R&D spend in core ICT is around $300 billion. So given this low level of R&D investments compared to global levels, the highly interconnected nature of global core ICT ecosystem, it is self-evident that a reasonable model for Indian headquartered companies is to join the global core ICT ecosystem. Like everyone else in this ecosystem, our companies can sell and buy IP and products in an interdependent manner. Ideally, India can emerge as a leader in some segments, perhaps wireless and conductor, where I know there are good skills. Also, the country should aim at a favorable balance of trade in this technology before the decade is out. South Korea is a great example of such success. Our Honorable Prime Minister understands this well, and I've met with him, and his exhortation to the country of self-reliance in core ICT is really for India to join this global ecosystem as an equal partner and as a valuable partner. It is time to join. A reasonable 10-year target for India in core ICT can be a 5% share of the global revenue, which would mean $250 billion of annual value addition by 2030, in 10 years. Even this 5% goal is a tough one. India will have to grow at 100% year on year, double year on year from our current low base to reach the target in 10 years. No doubt extremely challenging, but why not possible? So Indian engineers have it, I think, have what it takes. I know them well. I worked in India for many years. We have built a system which beat the rest of the world, like Sonas. I've done startups with mostly back-ended in India, for example, Besim Communications, where it was all done in India, and we had at one point 65% of the global market share in WiMAX, 4G WiMAX, built in India. So we have enormous engineering talent, but we need more than engineering talent to surmount a 30-year history of unfulfilled aspirations and sometimes unrealistic claims. Our current governmental structures are unfortunately siloed within different departments, and more importantly, are not really connected with the $1.7 trillion global ICT industry. Therefore, despite many well-meaning initiatives by the government over 3 decades, they simply have not been able to provide the thrust needed. We clearly need a change. India should create a new apex body to frame and implement policies that can effectively support the core ICT industry. That means to really create companies which are global and to grab some share of the global market share over 10 years. To build effective policies, this new apex body needs to develop, most crucially, and I think I would say again, underline crucially, a thorough understanding of the global ICT ecosystem, patterns of IP ownership, the various barriers to entry, including patents and technology transfer, the kind of investments needed, the structure of global venture capital and other financing methods, and the legal underpinnings and the case history of this highly litigious industry. As you know, this industry is full of litigations across countries and across companies. All successful core ICT powers have such bodies, certainly in Beijing and certainly in Washington. India also needs one. Such a body can be an effective support of India's fledgling entrepreneurs and nurture them most importantly, I think, attracting adequate global venture capital by offering effective incentives, as has been done in many other countries. I mentioned global because we need massive venture capital. I don't think just local Indian venture capital is right there. There are other reasons for global venture capital, as mentioned later. And other measures like developing meaningful market access policies for local and foreign companies, supporting these startups with inevitable litigation that success will surely bring, attract global talent in business development, sales, and product management areas, where I think they're still weak, and also develop appropriate physical infrastructure to support this industry. Global venture capital is critical because more than funds, it'll bring global connectivity to our startups, a must for their success. Vinod knows, and I also know, there are many startups that we are involved in within a year are connected across the globe. And I think the VCs do help them. So since core ICT capability is so crucial for India's economy, security, and international influence, to protect our core national interests, and we realize how that is important these days, I would therefore suggest that this apex body be chaired by the Honorable Prime Minister to give it the priority it deserves. Before I end, I would like to add my own motivation for building India's core ICT industry, a quest that has taken me to Delhi quite frequently in recent years. My dream for 30 years is that Indian core ICT industry will draw on the enormous talent within our wonderfully diverse and vast population, overcoming the massive challenges it faces, and these are not small. They're very difficult. Otherwise, after 30 years, we would have been in a better place. And with the help of the necessary government support, emerge as a valued partner in this global ecosystem. I think this too is the dream of our Honorable Prime Minister. I appeal for his personal support to make this dream come true. Thank you.
Thank you, Professor Paulraj. Thanks for such an inspiring talk. And it's been always our pleasure whenever we attend your talks. So, wanted to give a big round of applause. Please give a big round of applause for Professor Paulraj. So with that, sir, we have few questions, and I would like to go over those questions for you. The first question came that, sir, which areas in government should invest in for incubating fabless startup in the ecosystem? What's your views on that?
You know, it's a complicated thing. 5 years ago, there was a big attempt to try and do you're talking about fabulous startups. Okay, that's very good. Yeah, so, I keep telling the leadership in Delhi, companies have to be in the private sector. It's do or die. If a government sets a lab up or invests in a company, they can't compete. I mean, it's sold anywhere in the world. I'm against government investments in startups. Certainly, government can provide some kind of sweeteners behind venture capital investments. Venture capital should lead, and they, of course, will have to make sure that the company delivers or they get rid of the leadership and do whatever is necessary to succeed, and the VCs know how to do it. But in order to attract VCs, foreign VCs in this area, in core ICT, which is very risky, they have not largely come into India. There are a few. I myself are involved with some boards, but we are really at 1%, 2% of what we need. So I think I would like to see foreign venture capital, which is knowledgeable and who have the size to invest in Indian startups. But in order to make it happen, they need a lot of sweeteners. And there are a number of models in Israel, where I was involved with, Australia, and in Germany and UK. And we've got to find our own model by which we don't actually write the check for these companies. We do that, I think we will write a certificate of debt. They have to survive in the marketplace, so it's do or die. They've got to be funded by venture capital, who can bring in industry knowledge, but government can co-invest.
Okay, thank you, thank you. So, sir, on the same time, there was one more question. Is that there was one more question that today India is generating a lot of technologists. So, what sort of incentive we should provide so that they move towards the entrepreneurship path?
Oh, I think India has many great talent and it's amazing. Uh, but I think we have somewhat we've been become comfortable in India. We all have a fantastic standard of living, thanks to drawing salaries from Qualcomm and Intel, or from Infosys and Face and Wipro. So doing starting companies, since some of you have done, and Vinod has done that also, it's extremely hard, extremely hard. And so I think we've been spoiled. Easy money has come to us, and so we're not being motivated to take the risk and struggle and go through the various failures that are inevitable to start companies. So I'm thinking, in fact, we've been spoiled. But I feel that India as a country, we compare ourselves to what happened in China. I first went to China in 1993, and I keep telling the government that 93, India, because of CDOT, was ahead of China in telecom, well ahead. Today, there's no comparison. So it's a strategic requirement for the country to push this, and government should. But ultimately, it's entrepreneurs and risk takers. You got to do various things. You got to make sure that they feel it's worthwhile taking the risk, and if they see if the risk is so high, they're not going to do it. So the talent is there. It's up to the government and the ecosystem and all of us to get these entrepreneurs to give up well-paying jobs and go on a limb and take a risk and build companies. And I'm sure they will succeed. Of course, there'll be failures, but every company in the United States has been built on failures. So we need more risk takers in India, and I think we have them.
Thank you, sir. So, sir, next question is also another very popular topic, which is there in all semiconductor professionals' mind. When India is going to get the next fab? Now, we may not have a 5 nanometer fab or 3 nanometer gate all around, nothing like that, but maybe 40 nanometer or 28 nanometer should also be okay. So, what's your views on that?
Yeah, I think Vinod will also have views on it. And I was involved with 3 or 4 years ago. There was a major effort by the government. There was a select committee looked at the whole thing, but everything finally evaporated. So it's a catch-22 situations there because you know uh, it's complicated. For one thing, the actual skills for operating a fab, and if you go to TSMC, many of you might have been there, you can see the amount of knowledge of those engineers, whether it's Intel or TSMC or Global Foundry. So we have an enormously good base in building fabulous chips, but actually running foundries and in process technologies, we don't have a good base. So I think but the government today has not been able to put through a coherent policy because of reasons I mentioned. There's not enough knowledge in the system. But we can form an apex body where that body can bring in lots of skills, international skills, who can advise the government properly. It will take years, who can then create a coherent policy. We can do it. If China can do it or if Taiwan can do it, we can do it too. I think we don't have the structure now. We certainly can pull off fabulous companies, but the fabs is a more difficult thing. And it's been littered with problems over the years in India. So yeah, I don't have a magic solution, but surely we need to get there. But I think it's going to be a long journey, and it has to be a journey well informed by what's happening in the world.
Okay. Thank you, sir. The next question coming from Indian academia. The question is that what advice would you give to the deep tech startups originating from the academia in India? Because there has been a long, large valley of death on that. There is nothing significant coming out of that. So, what advice will you give to our academia?
And I would say that I know a lot of wireless researchers. I know many of them are sitting on this call, but we have very, very, very good people in India in wireless research, and some of them in Bangalore, Institute of Science. I sometimes co-write papers with them. We have them in Hyderabad and in Chennai and in Delhi, as good as anybody else in the world. And I do know the world fairly well. But one problem they have, of course, is I think there are two problems. One is, people like me at Stanford, even though I've done companies, I had a whole history of 10 years of consulting at the industry. So I would be involved with industry consulting. So I got to know how industry works. When you launch your startups, you have some understanding of markets, an understanding of opportunities, understanding of the difficulties you're going to face. So I think that is not there in our country as well as it should be. That's one problem. But the bigger problem is venture capital. We really do not have the venture capital that is needed. I myself, I'm fundamentally a professor and hardly an entrepreneur, but I myself have raised something like $119 million of venture capital. And I'm a small fry. I can't see anybody in India, a professor in India, raising anything like that. So we need venture capital to come in, and I think it's got to be foreign venture capital. But they only come in where they can make money. So it gives, once again, I think to go back to the point that the government has to play a role. Right now, things are questions get asked but never get followed through. I think we need to build a layer in Delhi to make this happen.
Okay, thank you. So next question, again coming from our academia side. So any cultural change do you suggest? So today, if you look at all the students after coming out of academia, they are trying to get a job in the MNCs. But all the Atmanirbhar India or the self-reliant India startups will be the key. So what do you suggest cultural change so that the Indian academicians as well as all the students, they also invest on the Indian startups, both in the research field as well as the human resource side also?
Right. No, I have great respect for our top universities and the students there, and our academics there are as good as anywhere in the world. But in fact, ultimately, we talk about nationalism and patriotism. It's fundamentally money that drives people. And certainly that's what drives people in China, and that's what drives people in the United States. And that's what made these countries. So India too, if a very bright young professor has to take a risk, sometimes he has to give up his job, give up his professorship. It doesn't happen at Stanford. India, our IITs, I think now they are better. Some years ago, you couldn't really do a startup. But to give up a job or give up a rather an easy life and take a risk to go in, and because at least a 50% chance he will fail, it's very difficult to do. But if he sees a huge reward, if he's going to make $100 million or $1 billion from that, with some probability, he will make it. I think we have to show one or two successes of academic startups doing extremely well at the international scale. Then I think the others will follow. So we need one or two lead outs, and then others will come.
Okay. So next question is also towards the innovation culture. So you have seen the innovation culture in India, you have seen in United States, and you have seen in a lot of other countries. So how do you compare Indian innovation culture with respect to rest of the world? And do you have any suggestion for that?
In every country has its own strength and maybe weaknesses. And I think India has their own strengths and weaknesses. So in the United States, so in China, I know these three countries pretty well, and been involved with many things there. And so I think on the net, we are not any different or any worse off or better off than any of these countries. And therefore, I don't see any negatives there, any deficiencies